Hello everyone, this is our channel MediMind. This is gonna be our second video in this channel. Here we are gonna discuss about various topics of medical science. We are gonna start a series about blood. Today in this video, we are gonna talk about RBC. Now what is RBC? RBC, also known as the red blood cells, are the most abundant cells in our blood. RBC are also known as erythrocyte. A major function of RBC is to transport the hemoglobin, which carries the oxygen from lungs to tissues. Now coming to the shape and size of RBC, normally red blood cells, as you all can see in front of your screen, are biconcave disc having a mean diameter about 7.8 micrometer or thickness of about 2.5 micrometer and 1 micrometer in center. The average volume of the RBC is 90 to 95 cubic micrometer. Now let's talk about the areas of the body where RBCs are produced. In the early week of embryonic life, nucleated RBCs are produced in the yolk sac. During the middle trimester of the gestation, liver is the main organ for the production of RBC, but some numbers are produced in spleen and lymph nodes. Then, during the last month of gestation and after the birth, RBCs are produced in the bone marrow. Now let's talk about what happens after birth. The bone marrow of essentially all the bones produce RBC until a person is 5 years old. The marrow of long bones, except for the proximal portion of the humerus and tibia, becomes quite fatty and produce no more RBC after the person is 20 years of age. Beyond this age, most RBCs continue to produced in the marrow of membranous bones such as vertebra, sternum, ribs and ilia. Let's talk about the stages of the RBC. The first cell formed in the RBC series is proerythroblast. Once proerythroblast is formed, it divides multiple times, eventually forming many RBCs. The first generation cells are called basophilic erythroblast. Now why they are called basophilic erythroblast? Because they stain with the basic dyes. In following generation, cell becomes filled with the hemoglobin. Nucleus becomes smaller in size and its final portion is absorbed from the cell. At the same time, endoplasmic reticulum is reabsorbed. This stage is known as the reticulocyte. During the reticulocyte stage, cell passes from bone marrow into the blood capillaries by a process called diapetesis. Now, what is a diapetesis? Diapetesis are the movement of cells by squeezing through the pores of capillary membrane. Finally, the remaining basophilic material in reticulocyte normally disappears within 1 to 2 days, then it becomes mature erythrocyte. Now let's summarize the stages of the RBC. At first, proerythroblast is formed. Then after the multiple division, basophilic erythroblast is formed. Then in following generation, a stage is formed known as the reticulocyte. During the reticulocyte stage, cell passes from bone marrow into capillaries by diapetesis. Finally, within 1 to 2 days, a mature erythrocyte is formed. Now let's talk about the stimulation of RBC production. Erythropoietin stimulates the RBC production. Now for the people who don't know what is erythropoietin, it is a circulating hormone which is secreted by kidney. Now how stimulation of the RBC production occurs? When a person is in a low oxygen atmosphere, erythropoietin begins to form within minutes to hours and becomes maximum in number within 24 hours. But no new red cells appear in a circulating blood until 5 days. The most important effect of the erythropoietin is to stimulate the production of proerythroblast from hematopoietic stem cells in bone marrow. And once Proerythroblasts are formed. Erythropoietin stimulates the cells to form more rapidly than they normally do. And finally, speeding the production of the RBC. What are the requirements for the maturation of the RBCs? Especially for the final maturation of the RBC, two important vitamins are required. Number 1, vitamin B12, also known as cyanocobalamin, and number 2, vitamin B9, also known as the folic acid. Both are essential for the synthesis of DNA because they both are required for the formation of thymidine triphosphate. By the way, thymidine triphosphate is one of the essential building blocks of DNA. Therefore, lack of either vitamin causes abnormal and diminished DNA and ultimately leading to the failure of the nuclear maturation and cell division. Now, erythroblastic cells of bone marrow fails to proliferate rapidly and produce many large normal cells called macrocytes. These poorly formed cells, after entering into circulating blood, can carry the oxygen normally, but their fragility causes them to have short lifespan. Therefore, it is said that deficiency of either vitamin B12 or folic acid causes maturation failure in the process of erythropoiesis. Now finally, let's talk about the lifespan of the RBC. The average lifespan of the RBC is about 120 days. When RBC are delivered from the bone marrow into the circulatory system, they normally circulate for 120 days before being destroyed. Even though the mature red cells do not have any nucleus, mitochondria or endoplasmic reticulum, they do have cytoplasmic enzymes that are responsible for metabolizing glucose and forming small amount of the ATP. But the metabolic system of the old red cells becomes progressively less active and cell becomes more and more weak because the lifespan is coming to an end. Once the red cell becomes weak, the cell rupture during passes through the tight spot of circulation and some other red cells self-destruct in spleen. So this was all about the RBC. All the information I have provided here are direct reference from Guyton and Hall textbook of medical physiology. I have tried to make this video easy for everyone. Hope this video will help you. Next video will be about formation of the hemoglobin. If you want us to upload more videos like this, please like and subscribe our channel Medimind. Thank you and take care.